So now for the next question, we are going to do the problem. Find the inverse Z transform of the signal x of z is equal to z into z minus 1 by z plus 2 the whole cube into z plus 1. Okay, and here for this given question, the ROC is magnitude of z greater than 2. So from here you can understand, since it is a greater sign over here, you can understand that this is a causal signal. All right, so now you are going to factorize this, right? So before factorizing this, you need to make this equation in this format, x of z by z, right? Because you need to protect this z so that you can put it in the numerator at the later stage. So this x of z by z is equal to z minus 1 by z plus 2 the whole cube into z plus 1. Okay, so now we are going to factorize this. All right, so to factorize this, you should understand here there are two factors, right? One factor is distinct and the other factors is repeating factors. It is repeating 3 times, so which means that you need to write this factors 3 times, right? So totally there are 4 coefficients you need to find, which means this should be factorized like this. That is a by z plus 2 plus b by z plus 2 the whole square plus c by z plus 2 the whole cube. Okay, these 3 terms represents this factor z plus 2 the whole cube, right? Just like your Laplace transform and your Fourier transform, for all where you have applied partial fractions, this procedure is exactly the same, right? If it is a repeating factor, you repeat that many times in the increasing order of its denominator, power of its denominator, plus, and the last one is z plus 1. So I will write d by z plus 1. Okay, so now you need to find the value of a, b, c and d. Okay, so first we will find the value of c and d. The reason is because c and d contains the complete factors, so the way of finding c and d is exactly the same of the previous coefficients that you have studied before. Same way how you found the value of the coefficients, you can find the value of c and d. That means the value of d, I can quickly find that d is nothing but the denominator of d is z plus 1. So remove z plus 1 from here and write the remaining terms, that is z minus 1 by z plus 2 the whole cube. Okay, and also z plus 1 is equal to 0, therefore z is equal to minus 1. So therefore substitute the value of z over here as z is equal to minus 1. So you will get minus 1 by, this will become minus 1 plus 2 the whole cube. Alright, so minus 1 is minus 2 and minus 1 plus 2 is 1, so you will get over here as minus 2. Okay, so now I found the value of d. Next I am going to find the value of c. C also same procedure, because C contains the complete factors, right? Z plus 2 the whole cube, Z plus 2 the whole cube. So the factor is the same. You cannot find the value of B and A directly from here. Just like how you found the value of D and C, you cannot find the value of B and A because B and A has incomplete factors, right? So first, now I am going to find the value of C. So to find the value of C, I am going to, here the denominator is z plus 2 the whole cube, so I will remove z plus 2 the whole cube from here and write the remaining expression, that will become z minus 1 by z plus 1. Okay, and the value of z I am going to substitute as minus 2, because z plus 2 is equal to 0, so z is equal to minus 2. So you will get, here you will get minus 2 minus 1 by minus 2 plus 1. So you will get minus 3 by minus 1, which is nothing but 3. So now I found the value of C. Now next I am going to find the value of B. So now to find the value of B is going to be a little tricky. You have to apply that formula to find the partial fractions, right, for an incomplete factor. So here you can see that z plus 2 the whole square, but the given factor is z plus 2 the whole cube. Therefore the formula is 1 by 3 minus 2 the whole factorial d by dz, and just for your easiness I am saying simply apply the expression of this, of the previous values. So here the previous values z minus 1 by z plus 1, so apply that expression over here, z minus 1 by z plus 1. Okay, this is the value of B, and substitute the value of z as is equal to z is equal to minus 2. So this is how we find the value of B. Okay, That is, first I found the value of c, right? C has the complete factor. So I found the value of c by removing z plus 2 the whole cube from the denominator and substituting the value of z as z is equal to minus 2. Therefore, I found the value of c as equal to 3, right? So this is the expression of c and this is the value of c. Now to find the value of b, that is the next one, right? That is 3 minus 1, 2. So to find the value of b, simply apply the equation 1 by the total factor is 3. So 3 minus the present factor is 2. So 3 minus 2 factorial d by dz of the previous expression. The previous expression is this one, z minus 1 by z plus 1. Okay. So from here this is nothing but 1 by 1 factorial is 1 itself, and here it is d by dz of z minus 1 by z plus 1. So you can apply u by v equation. So you will get v into du, that is z plus 1 into du is 1 minus u into dv, u is z minus 1 into 1 by z plus 1 the whole square, right? So you will get over here as z plus 1 minus z plus 1 by z plus 1 the whole square. So you will get over here as this z and this z will get cancelled, and you will get 2 by z plus 1 the whole square. Okay, and substitute this value of z as z is equal to minus 2, right? So this is the expression of b, and now you simply substitute the value of z as z is equal to minus 2. You will get 2 by minus 2 plus 1 the whole square. So minus 2 plus 1 is minus 1, minus 1 the whole square is 1. So the value of b is 2. So now I found the value of b. Same way, now to find the value of a, okay, here like I said before, the total factor is 3. So 1 by 3 minus, okay, 1 by 3 minus the present factor is raised to 1. So 1 into d by dz of the previous expression. Here the previous expression is 2 by z plus 1 the whole square. So 2 by z plus 1 the whole square. That's all. Okay. So you will get over here, this is 1 by 3 minus 1 factorial. Yes, factorial. So 1 by 3 minus 1 is 2 factorial. So 2 factorial is 2 itself. So you will get over here 1 by 2 into, now to apply d by dz of this, I'm saying I'm going to apply u by v equation. So it will become, so this will become v into du is 0 minus u into dv. dv is this one. Differentiation of this is into 2 into z plus 1 by z plus 1 the whole raised to 4, right? Whole raised to 4, right? 2 into z plus 1 the whole raised to 4. This 2 and this 2 will cancel, so you will get minus 2 into z plus 1, and this z plus 1 will get cancelled, right? So it will become minus 2 into z plus 1 the whole cube. Now substitute the value of z as z is equal to minus 2. So in that case you will get here minus 2 plus 1. Minus 2 plus 1 is minus 1. Minus 1 the whole cube is minus 1, and that minus 1 and this minus 2 will get cancelled, and you will get the value a as equal to 2. Okay. So now you found the value of d as equal to minus 2, c is equal to 3, b is equal to 2, and a is also equal to 2. Now you need to substitute the value of a, b, c and d over here. So therefore x of z by z is equal to, let me see, it is a, the value of a is 2, so it will become 2 by z plus 2 plus the value of b is 2, so it will become 2 by z plus 2 the whole square plus, and the value of, let me see, the value of c is 3, so it will become 3 by z plus 2 the whole cube, and the value of d, let me see, the value of d is minus 2, so it will become minus 2 by z plus 1. Okay. So now I am going, so since I have already protected this z, now I am going to put this z into the numerator. So therefore, x of z is now, it is 2 into z by z plus 2 plus 2 into, here it will become z by z plus 2 the whole square, and here it will become plus 3 into, here it is z by z plus 2 the whole cube, and here it will become minus 2 into, here it is nothing but z by z plus 1. Okay. So now this is how, now you need to apply the z inverse equation. That is, now we know that x of n is equal to 2 into z inverse of z by z plus 2 plus 2 into z inverse of z by z plus 2 the whole square plus 3 into z inverse of z by z plus 2 the whole cube minus 2 into z inverse of z by z plus 1. Okay. So this is why I put this z over here. This is the reason why I put this z over here. Right, the reason why I put this z over here is because since I can put this z back to the numerator. That is why I protect this z. That's why in the previous problem also I did this procedure, so that I will get this kind of an expression, because we know that the z inverse of, according to your inverse formula, the z inverse of z by z minus a is equal to a raised to n u of n. This is the expression, right? So therefore z inverse of z by z plus 2 is nothing but, let me see, here the value of a is minus 2, so therefore it will become minus 2 raised to n u of n, right? Also z inverse of, let me see, this one, z by z plus 1 is nothing but minus 1 raised to n u of n. See, and also we know that the z inverse of z by z minus a the whole square is equal to n into a raised to n minus 1 u of n, right? Therefore the z inverse of z by z minus a the whole square is nothing but, let me see, here the z, no, I'm sorry, here is z plus 2 the whole square, z plus 2 the whole square. So here the value of a is minus 2, so therefore it will become n into minus 2 raised to n minus 1 u of n, right? And also we know that z inverse of z by z minus a the whole cube is nothing but n into n minus 1 by 2 factorial a raised to n minus 2 u of n. Therefore the z inverse of, according to your question, z by z plus 2 the whole cube is equal to n into n minus 1 by 2 factorial is 2 itself, and the value of a is here a is equal to minus 2, so it will become minus 2 raised to n minus 2 u of n. Okay, u of n. So now I am going to substitute all these values in the given expression. Therefore x of n is equal to, therefore x of n is equal to 2 into, so let me see, it is minus 2 raised to n u of n plus 2 into z by z plus 2 the whole square. As this one over here, it is nothing but n into minus 2 raised to n minus 1 u of n, then plus, now let me see, next is 3 into z inverse of z by z plus 2 the whole cube, that is over here. It's nothing but 3n into n minus 1 by 2 minus 2 raised to n u of n, okay, plus minus 2 and z inverse of z by z plus 1, that is over here, is minus 1 raised to n u of n. So this is your final answer. Okay.